You look at your notes, they tell you that you want to draw a picture if you can, and you're going to have a primary equation and a secondary equation. And the way to know what your primary equation is that's going to be the thing you're maximizing or minimizing. So reading this question says the size of the population of a bacteria introduced into a food grows according to this formula, where T is in weeks. Determine when the bacteria will reach a max. So we want the population of bacteria to be a max. We're trying to get the maximum size of bacteria. And then we want to find that maximum size. So we want to maximize this function, because that is the population. So this one's a little easier than the others because everything in this problem is already in one variable. So whenever you're thinking about maximizing or minimizing something, what are you thinking about that you're going to have to use? What do you got to do when you're maximizing or minimizing? What should pop into your brain that we got to do?
We have to find the derivative when it's at 0.
That's right. Maximizing and minimizing should be derivatives. Okay, and then once you think about that, is the next thought that should pop into your mind is we have to find the what of the derivative. We got to find the what numbers.
Critical numbers.
We have to find the critical numbers. Okay, so we're going to have to do the derivative of this. So this is going to be a quotient rule because we have a fraction. So P prime is going to be, and I take the bottom. And some of you are doing this wrong on your test, by the way. When you take a binomial as a bottom, you must put that in parentheses because we take the bottom derivative of the top. If you do not put that in parentheses, if you write this and do not put that in parentheses and write this, this is wrong. Writing this right here is wrong. You will lose a point for this because this is distributive property. And if you write it like this, the only thing you're taking the 60 time is t squared. So if you write that, you will lose a point on the AP test. That's called linkage error. Okay, so going on with this property, it's bottom derivative of the top minus the top times derivative of the bottom. And that's all over the bottom squared. So then what I think you should do on this kind of problem is take out GCFs is what I think you should do. And then we will simplify. So if you look here, there's a small factor of 60 and a factor of 60. So the very first thing I would do is factor that 60 out. And then that's going to leave this 60 plus t squared minus, over here, you're going to have minus 2t squared. Because that t times that 2t is that. Now, we are going to want to add like terms here. Up here on this part right here. So we are going to end up having 60 times 60 minus t squared all over 60 plus t squared. Now there, I'm sorry, I wrote that wrong, didn't I? I forgot to square my bottom. Don't forget to square your bottom or you'll miss it. So there's my p prime of t. So my next goal is to find where my critical numbers are. So that's where p prime equals 0 or where p prime is undefined. Those are the places where critical numbers occur. So, and now if I do this top part, I would only take the part inside the parentheses and set it equal to 0. And here's the reason. If you have this 60 out here with these parentheses, the first thing you do is divide each side by 60, which still gives you the inside equals 0. So I would do this, and then I'm going to add t squared over, and then I'm going to square root. So I got plus or minus the square root of 60 for t. And then to get where this is undefined, this is where this is going to equal 0, because you cannot have 0 on the bottom. And again, you could, this is another mistake I made, is you could put this in parentheses and square it, but the first thing you're going to do, oops, I got more people coming late to the meeting. But the first thing you're going to do is square root this. So when you square root 0, you still get 0 on this side, and that gets rid of that square. So you do not have to do that. Now, when I see this, I immediately know the answer. I don't get any critical numbers from this because any number I square is going to be 0 or positive. And 60 plus, that means this is never going to be 0. So there's none from this. Now, if you don't realize that looking at it, you can subtract 60 over, and as soon as you square root now, you got a negative inside the radical. Those are imaginary numbers. That means there's no critical numbers from this. But if you realize this is never equal to 0 right here, you don't have to, the people in AP Calculus expect you to know numbers well enough that you don't have to show you get imaginary. So it's okay if you just go right to none right here. All right, so we have 2 critical numbers. So I want to take these critical numbers and put them on a number line. So it looks like I'd want to do this, doesn't it? But does anybody remember what is T? T's representing what?
Time.
Time in weeks, right? So when you start an experiment, are you allowed to go back in time?
No.
No. So something we should realize is that T has to be greater than or equal to 0. So in this actual problem, we don't need, you don't want to use that. You want to start at 0. And since we're not going to go back in time anywhere, we would just do this. So our time is, our only critical number we're worried about is the square root of 60. Now I think it's easier to figure out numbers on each side of square root of 60 without simplifying this, because I know the square root of 64 is 8, and I know the square root of 49 is 7. So this is going to be closer to 8. I'm going to say maybe 7.8-ish. I don't really know, but I'm going to pick a number on this side. So I'm going to make sure, I'm going to pick 1 over here, and then I'm going to get a number over here. I'm going to go ahead and pick 8 on this side. And I want to know, does that make this a positive or a negative? So if I pick 1 and stick, well, first of all, I know we already talked about this. We know the bottom's positive no matter what. So I need to find out what the top is. If I put 1 in here, I'm going to have 60 minus 1. That is definitely a positive, so we're positive here. And then if I put in like 8, let's say I stick 8 in here, that's going to be 60 minus 64 is a negative. So that'd be a negative, so this is negative. So that means that P prime means that function P is increasing to the left of radical 60 and decreasing to the right. So my max is going to be right here. Okay, that's a relative max. So, and because this is increasing forever from 0 to there, I really don't need to check 0. But if you want to put P of 0 in there to see the bacteria you started with this, you're allowed to do that, but it's going to be 0 because you plug 0 in there and you get 0 divided by something. So square root of 60 is going to be my max. So I want to find out the number of bacteria I have. So I've got to do P of square root of 60, which I think was 6,000 times T all over. I go back up and look at it. I think it was 60 plus T squared, wasn't it? Yeah. So I got 60 plus T squared. You can leave your answer right like that. That's fine. Now, if you want, you can simplify, but you do not have to. Now, if it's multiple choice, you would probably have to simplify it. So we're going to say the bacteria reached a max of 6,000 times the square root of 60 over, I don't know, maybe you want to make that 120. You can, you don't have to, because that cancels the square root out and that's 120. You could reduce more if you wish. Bacteria, and we probably should put a squiggly here, at T equals square root of 60 weeks. And then to justify, because P prime changes sign from, some of you did not do this on your quiz, from positive to negative at P P, oh, not P, T equals square root of 60. And you should call what this time is in right there, because it told me in the problem way up there at the top, if you look at it again, it's in weeks. Anybody else got anything you want to see off of this?
Number 9.
I already did number 9. I put it on the video today. So if you go in there and look today, number 9's on there. Are there any other ones anybody wants to see?
Number 2.
Number 2. All right, so let me find number 2. Worksheet. I think it's right here somewhere. There it is. All right, let's do number 2. I'm going to get a picture of it again. Again, number 9, I did number 9 this morning in second period, and I made a video of it. So there's a video of number 9, and there's a video of number 2 on the notes corrected. So you can find that on the, if you want me to show you where it is on Canvas, I can do that. Just say yes if you want me to show you where it is. So I'm hoping this one has, I should have turned the lights on. That's kind of dark, isn't it? All right. So this says find a non-negative numbers for x and y whose sum is 75, for which the value of x, y squared is the largest possible. So what we have here, this is going to be a primary equation and a secondary equation. And the thing that tells you which is the primary is what we are doing, which thing we are doing. Now, do you see this says that we want, let me get a highlighter. We want this to be as large as possible. So that is my primary right there. So I'm going to just say, I'm going to put P for primary. So my primary equation is P equals xy squared. And large means I want to maximize this equation right here. So that's my primary equation. And then this is where I get my secondary equation right here. Now this says find non-negative, so something you probably should write down is, hey, we want x to be greater than or equal to 0 and y to be greater than or equal to 0. So we're not worried about any negative numbers here. And it says we want their sum, so x plus y has to be 75, and that's my secondary. So I'm going to take this information and solve this for one of the variables and stick it over here in order to find the as large as possible number I can get here. So I'm going to solve this for y. It didn't really matter. You can solve for either one. And I'm going to stick 75 minus x in there for that y. So x times 75 minus x squared. And we can do product rule here. Okay, we can do product rule here, or I can go ahead and simplify that. What would you guys do?
Simplify.
All right, so I've got to take 75 and square it. I don't have that one memorized. I don't know if any of you do or not. So that's 5,006. So I got x times 5,625 minus 75 times negative x times 2. So that's going to be minus 150x plus x squared, and then you distribute that x in there. Now what I would have done is I would have done product rule here with chain rule, but you don't have to. You can do, the reason I would do that is this multiplying takes up extra time. That's why I would do that. So there is my function simplified. And if you guys want, I can show you, we'll get the same answer either way if you want to see it. So anyway, there's my P. So now I'm going to do P prime over here, because that's what I'm maximizing is this thing. So I'm going to get 5,625 minus 300x plus 3x squared. So now I want to find where is p prime equal to 0, where is p prime undefined. Well, since there's no x's in the denominator, there's none for this. So there's nowhere it's undefined. This is a continuous function. Now, if I look over here, if I add these numbers up, 7 and 11 is 18, all these numbers are divisible by 3. So to make my factoring a little easier, I'm going to divide everything by 3 here. So let's see, we're going to have minus 100x plus x squared equals 0. And 5 is 1. I'm going to cheat and use my calculator to save some time. Let's see, 5675 divided by, oops. Oh, I put the wrong number in. That's 25, not 75. 1875. All right, so I need to try to find factor. Now I could do quadratic formula here. I'm pretty sure these are going to be integers. I don't know. So I'm going to play around with some factors of 1875 to see what this is going to be. So this is going to be a negative x and a negative x. I could have flipped them around too, but it doesn't matter. So I got to find factors of 1875. So that's a difference of, oh, there we go. So 25 and 75 are factors of 1875 that if I check the middle two, gives me a negative 100. So what that means is x can equal 25 or x can equal 75. So if x is 25, I want to find y. So if I come over here and plug 25 in there, I get y is going to be 75 minus 25 would be 50. And if I want to try this one, y would be 75 minus 75. That would be 0, right? So which one of these would give me the best number for x, y squared? You know what? I screwed up. This is going to be my minimum value. That's my maximum. So I should have made my number line. So let me make that number line real quick. So my critical numbers were 25 and 75, and I'm plugging those into p prime. So I'm plugging those into this thing right here. So if I pick a number, remember we want non-negative, so we can't go less than 0. So if I pick the number 1 and stick in here, you got a positive times a positive is a positive. Okay? And then if I stick in, let's say, I don't know, 50, that'll be a negative times a positive is a negative. And then if I put in a number greater than 75, let's say 80, I'll get a negative, and a negative is a positive. So I have a relative max here, and I have a relative min here. And if you remember, we want a maximum. So I do not want the 75, so I kind of wasted my time doing that one. So we are going to say xy squared will be a max when x equals 25 and y equals 50, because p prime changes sign from positive to negative at x equals 25. Okay? Anybody else got anything you want me to do? Does anybody need me to show you where number 9's video is? I'm getting nothing from anybody. Okay, I'm going to stop the video here, but I do have a question for you guys about turning in your quizzes. I have had